The next trend we looked at was electron affinity. Electron affinity is the energy change associated with the addition of an electron. Now, we have to be careful because some atoms, when they gain an electron, we have to add energy to get them to take it on. And these are generally our metal atoms because they don't want to gain. Whereas some atoms will give us energy. These are our nonmetals because they form a more stable entity. Now, when we're adding energy, if we were to look at it, we would see that added energy, this is a positive value, whereas if we lose energy, give off energy, it'll be a negative value. So if we look at our trend, we can see it's a little harder to see, but we can see that as we go across a group in general, or sorry, across a period in general, we can see that my electron affinity becomes more negative, or I give off more energy. The other thing we can see is if we go down a group in general, this would be our trend. That would tell us is that we give off less energy, or I require more energy. Okay, so within a group, as we go from top to bottom, my electron affinity becomes more positive or less negative, meaning I either need more energy or I release less energy. And it's because the distance increases and there's lower force of attraction. So therefore, it will change the amount of energy change that occurs. Whereas if I go across a period, it becomes more negative or less positive. And this is because our distance stays the same, but our ENC increases. So when explaining electron affinity, remember, it's important to explain in terms of what you call define it. So whether you're saying electron affinity is going to be the energy required to gain an electron, or it's the energy released, then you'll just use that same terminology or that same perspective when you're comparing atoms. Our final trend that we looked at is electronegativity. And electronegativity is a measure of an atom's ability to attract a bonding pair of electrons, looks at how it would share it with other atoms. Okay, and if we look, we can see that as we go down a group, my electronegativity decreases. But as I go across a period from left to right, electronegativity will increase. Okay. Similar to the other trends, as I go down a group, my distance will increase. Therefore, because my electrons are added to energy levels further from the nucleus, I'll have a lower force of attraction. So therefore, I'll be attracting the electrons that are in a bond less. As I go across a period, my distance stays the same. Electronegativity increases as a result of our ENC changing. And that will give it a greater attraction to the bonding pair electrons.